What's up guys, my name is Sehring and I'm going to be giving my presentation as the lead for the clapper-on experiment. So let's go over our experimental goals. Our main goal is going to be to determine the latent heat vaporization of water, and we're going to do this by measuring a bunch of pressures and temperatures in the experiment and then using a formula to back out that vaporization temperature. Here we have some practical applications for the clapper-on experiment. I think the coolest one is meteorology. Basically, when they're forecasting rain and stuff like that, they're looking at the atmosphere and they're saying, all right, is there water vapor out there? What's its temperature? What's its pressure? Is it going to form a cloud? And is that cloud going to precipitate? Which is pretty cool. The steam turbine, we had someone present on the raking cycle earlier, so a lot of overlap there, where you want your steam to be at a specific temperature and pressure to get that optimal flow for the turbine to work properly. And the refrigeration cycle, we had a couple of presentations to talk about that, where rather than water with these, you're looking at the coolant, making sure it's having the proper flow rate based on its temperature and its pressure. All right, so theoretical background, this is the equation I was talking about a little bit earlier. This is the only equation we use for this project, where HFG is the latent heat vaporization of water. That's what we want to find. We'll later manipulate this equation to get that. PSAT is the saturation pressure of water. T is the saturation temperature, and R is our specific gas constant. For our procedure overview, I made it pretty simple. We're basically going to turn on a vacuum pump to lower the pressure of the water, and then we're going to turn on the hot plate and bring it to a boil. Then we're going to start recording our data so we can start getting points, and then we're going to slowly close the pump line to increase that pressure back up to find temperatures over that pressure range. Here we can see what that process looks like. Here we have our water in a flask where it's being heated. Over here is where we have our vacuum pump where we're going to get the water from, get some pressure going into there, heat it, and then here's our computer that is going to take all the data for us. And we have some predicted results. Over here is just a sample pressure, temperature graph. We expect to get something similar, obviously not quite because we're not perfect, we're not going to get the same exact thing. And over here we have a sample calculation based on some ideal values for temperature and pressure. So at a temperature of 100 degrees and pressure of 101 kilopascals, we expect to get a latent heat vaporization of around 1972 kilojoules per kilogram. But obviously we won't get that exactly. That's all I got. Any questions?